Hi friends, welcome to my channel. Myself Spandana.K of CSE department studying at Shiventishwara College of Engineering. Today we are going to discuss about this subject, that is microcontroller and embedded system. The subject code is 21CS43. Now let's get into the topic. Topic that we are going to discuss today is data processing instruction. There are different types of data processing instruction. In that we are going to discuss what is logical and comparison instruction. Topics that we are going to cover are types of data processing instruction, introduction of logical instruction and comparison instruction, logical instruction and comparison instruction explanation including types and example. Now let's see the types of data processing instruction. The first one is arithmetic instruction, move instruction, comparison instruction, logical instruction, and multiply instruction. These are the types of data processing instructions. In this, we are going to discuss what is logical instruction and comparison instruction. First, let's discuss what is logical instruction. Introduction to logical instruction. These are the instructions that perform basic logical operations such as AND, OR, etc. Logical operation works on a bitwise level. Logical instructions are fundamental operations in computer programming and digital electronics that deal with logical operations on binary data. These operations involve manipulating binary values, that is zeros and ones, to make decisions, comparison, and perform other related tasks. Logical instructions are typically executed by central processing unit, that is CPU of a computer or a microcontroller. Now let's see some examples and types of logical instructions. First one is AND, which is known as logical AND. The AND instructions takes two binary inputs and produces an output where each bit in the output is 1. Only if the corresponding bits in both inputs are 1. Otherwise, the output will be 0. That means if both the inputs are 1, then the output will be also 1. If both the inputs are 0, then the output will be 0. Let's see an example for this. If input A is 11010100 and input B is 10101110, then the result will be 10000100, because if both the inputs are 1, then the result will be 1. If both the inputs are 0, like if input A is 1 and input B is 0, then the result will also be 0. If input A is 0 and input B is 1, then the result will be 0. If both the inputs are different, then the result should be 0. If both the inputs are 1, then the result will be 1. And if both the inputs are 0, then the result will be 0. Now let's see what is OR, which is known as logical OR. The OR instructions also takes two binary inputs and produces an output where each bit in the output is 1. If at least one of the corresponding bits in the input is 1. If both the inputs are 0, the output will be 0. Let's consider an example. Input A 11010100 and input B is 10101110. Then the result will be 11111110. If both the inputs are 1 and 1, then the result will be 1. If both the inputs are 1 and 0, then the result will be 1. If both the inputs are 1, then the result will be 1. And if both the inputs are different, like 1, 0 or 0, 1, then the result will also be 1. If both the inputs are 0, then the result will be 0. Now let's see what is XOR, that is logical exclusive OR. The XOR instructions takes two binary inputs and produces an output where each bit in the output is 1 if the corresponding bits in the inputs are different. One is 0 and other is 1. If both the inputs are same, both 0 or both 1, then the output will be 0. Let's see an example for this. If input A is 11010100 and input B is 10101110, then the result will be 01111010. Because if both the inputs are same, then the result should be 0. If both the inputs are different, then the result should be 1. Now let's see what is not, that is logical not. The not instruction, often referred to as a complement or inversion, takes a single binary input and produces an output where each bit is the opposite of the corresponding bit in the input. 0 becomes 1 and 1 becomes 0. It is a simple instruction where it is easy to understand very fast. Let's see an example for this. If input is 11010100, result will be 00101011 because it is the inverse of input. That is, if input is 1, then the result will be 0. If the input is 0, then the result will be 1. Logical instructions are widely used in various applications, including programming, data processing, digital circuits, and Boolean algebra. Executing the logical operation. The CPU performs the logical operation according to the instruction logic. For example, for AND operation, the CPU will perform a bitwise AND between two operands. They play a crucial role in decision making, bit manipulation, and performing arithmetic operations using bitwise operation. In programming languages, these logical instructions are often represented using a symbols. For example, these are the symbols of AND, OR, XOR, and NOT. Now let's see comparison instruction. Comparison instruction, also known as conditional instructions or comparison operation, are fundamental operations in computer programming and digital electronics that allow you to compare two values and make decisions based on the result of comparison. These instructions are used to implement branching and conditional statements in programming language and control flow in computer programs. Now let's see some types and examples for comparison instruction. The first one is compare, which is represented as CMP. The compare instruction is used to compare two values, usually operands in the register or memory locations. It performs a subtraction operation but does not store the result. Instead, it sets flags in the processor status register based on the outcome of the comparison. Common flags include the 0 flag, set if the result is 0, and sign S flag, set if the result is negative. Example for compare is CMP A, B. That is, we compare the values in the register A and B. Now let's see another type, that is compare negative, which is represented as CMN, flag set to result of Rn plus operand 2. The next one is bitwise test, which is represented as TST. The flag set to result of Rn and operand 2. That is, here we perform a multiplication operation. The fourth one is test equivalent, which is represented as TEQ. The flag set to result of RNEOR, that is exclusive OR of operand 2. Thank you for watching this video. Have a nice day.